A very good morning. My name is Mohd from RK23. So I'm going to present about the analysis of three-phase Y connector generator. So we I'm going to start with the introduction part. Okay, so what is the three-phase Y connector generator? So I'm going to just tell about the introduction first, which is uh, so from a large portion of the electrical vitality utilized on the wall is alternating current or AC, where it is utilized three-stage system. The estimation of substituting current varies between the maximum positive value and the minimum positive value, with a zero reference which name is neutral or ground. At this point, when just a solitary sine wave is produced, the electrical flow is elided as single-stage flow. Three-phase rotating flow electrical vitality is created by a three-phase generator and transmitted more than a three-stage framework and wiring. There is a few reasons why three-phase is wanted to a single stage for service in so many applications. So what is a single phase system? So single phase system is actually the power delivered by a single phase circuit is pulsated in sinusoidal wave pattern of voltage, current, and power are shown for a resistant load as the phase same between the voltage and the current is the same. This means that the power factor of this system is unity, which mean power factor is the cosine of the angle between voltage and current. At unity power factor, the power is zero twice each cycle. So what is a three-phase system? Three-phase system is actually the total power supply to a balanced three-phase circuit. It's not a variable wave, but it's a constant value. Adding the power for all phases together at any time will create a constant value. Mathematically, the above can be easily proven. For balanced three-phase circuit, the addition of 1 point of all three-phase voltage or for all current at very instant is 8 to 0. Next, so we have three objectives. The first objective is to analyze the three-phase Y connected generator in electrical system. Next, to evaluate the parameter of the connected Y generator in the context of transmission and load impedance, current, and voltage, acceptable voltage drop. And the last one is to study and evaluate the active power absorbed by the loss by using 2 wattmeter method and the conventional measuring method. So for the methodology part, we use the PSIM software to create this circuit, to create this type of circuit. So in this test, the student are randomly assigned the value of line voltage, the value of V line to line that assigned for me is 132k voltage. By using the value, we managed to calculate the value of the voltage phase. Can Okay, so for the methodology part, we use a PSIM software to create this type of circuit. So in this test, students are randomly assigned the value of the voltage. So for me, I get the 132,000 voltage. So by using this value, we managed to calculate the value of voltage phase. Here, so the formula to get the voltage phase is this. Voltage line to line is divided by the square root of 3. So the transmission loss for me is equal to 59 plus J12, and transmission load for me is 81 plus J9. So here is the voltage of here's the formula of the voltage drop, which is equal to V supply minus V load over the V supply. So we need to calculate the value of total power that delivered to the load by using conventional method and 2 wattmeter. So for the result in discussion, the this is the E line to line that I get, which is 132 kilovolt. So the transmission loss is 59 plus J12, and the transmission loss is the 81 plus J9. So the formula of the Z total is equal to ZL plus ZS, which is equal to 140 plus J21. So the formula of E line is equal to square root 3 of E phase. So E phase is I get E phase, which is equal to 0.577 times with 132 kilovolt, which is equal to 76.16 kilovolt. So I get the value of EAN, which is equal to 76.16 angle 0, EBN 76.16 kilo angle 120 volt, and ECN I get 76.16 kilo angle negative 120 volt. So for the current IAA, I get the formula is IAA is equal to EAN over ZT, which is equal to 0.538 kilo angle at negative 8.53 ampere. And for the IBB, I get 0.538 kilo angle 111.47 ampere. And for the ICC, I get 0.538 angle negative 128.53 ampere. So for the other result and equation, the formula of EAN, which is equal to IAA times ZL, which is equal to 0.538 kilo angle negative 8.53 times with 81 plus J9, which is equal to 43.85 kilo angle negative 2.19 voltage. So for the EBN is the same. What I get is 43.85 kilo angle 117.81 voltage. And for ECN I get 43.85 kilo angle 122.19 voltage. So the other part is PA is equal to EAN times IAN cos theta. PA is actually a power absorbed. So power absorbed that I get is 23.45 megawatt. So the formula in order to find P total, the formula is 3 times 23.45 megawatt, which is actually P total is actually 3 times the power absorbed. So I get 70. So for the P total, power total, that I get 70.35 megawatt. So for the discussion part, based on the result and conclusion. So from the result that we get, it shows that the line current, which is IAA, IBB, and also ICC. From the cumulative value of the line current obtained from the measure value of line current from PCM, the measure value of the line current are slightly different as being compared to the cumulative value of line current. So is the measure value different with the coefficient value? Yes. And the reason why is it different is because the measure value of the line current are slightly different as being compared to the calculated value of the line current plus the result show the value of the phase voltage of the load, phase voltage of load A, load B and load C were calculated and recorded. There is a slight difference, like say, between the value of phase voltage measured as the result. So from the result, we can conclude that the calculated of the phase voltage of load is slightly less as compared to the phase voltage of load is slightly less compared to the phase voltage of the load calculated. Then the result show the value for line EAN, EBN, and ECN. The value calculated line voltage have slightly different as compared to the value of measure line voltage as observed from the table. The value of voltage is slightly less than the value of the active power gain by the load. They are a bit different in the value of calculated active power as being compared to the measured active power using 2 wattmeter, as it obtained by the value of measured active power using 2 wattmeter method is less than the value of calculated active power. Hence, the value of voltage drop percentage with the 33 kilovolt of generator is 47.56, which means it had exceeded the acceptable voltage drop. So what is the uses of Y configuration? So basically the Y configuration is used to distribute the power to everyday single phase appliances for in our home, such as office, and maybe for the school also. Since the insulation is decided by phase voltage and for Y connection is 0.577 times higher times line voltage. So for the interconnection, phase voltage and line voltage are equal since the insulation level is decided by the phase voltage and for the Y connection. Phase voltage is 0.577 times line voltage and hence the insulation required in Y connection is nearly 57.7%, where can be used for high voltage connection than the insulation that we require in the interconnection for the same line. For the same line of voltage, and hence it will cost for insulation will automatically be reduced. Neutral point that neutral wire can be drawn using the neutral wire, and any one phase can be used as a split phase. That's all from me. Thank you.